In this video, we're going to discuss the calculation of the purchasing power parity exchange rate. But first, some preliminaries. Purchasing power parity requires that the price of the good in the domestic and the foreign economies be equalised. So we have P equals E times P star, where P is the price in the domestic country, E is the exchange rate, which is expressed as units of domestic currency per unit of foreign currency, and P star is the price in foreign currency of the good in the foreign country. So in this form, P equals E P star, we are given the domestic price level, which is consistent with PPP given the exchange rate and the foreign price level. But as an alternative, we could calculate the purchasing power parity exchange rate. This is given by the expression here, E equals P divided by P star. And this gives the exchange rate, which is consistent with purchasing power parity given domestic and foreign prices. One thing to note throughout is that E here is the exchange rate and is defined as units of domestic currency per unit of foreign currency. Therefore, an increase in E constitutes a depreciation and a decrease in E constitutes an appreciation with respect to the domestic economy. Next, we make use of these concepts to calculate the purchasing power parity price level and the purchasing power parity exchange rates. The purchasing power parity price level is given by the product of the exchange rate and the price in the US. So for Indonesia, we have the product of the exchange rate of the rupiah and the dollar multiplied by the price in dollars of a Big Mac. And we do the same calculation for Switzerland. So we take the exchange rate, Swiss francs per US dollar, and multiply that by the price in dollars for a Big Mac in the US, and we get a value of 4.97. Then to calculate the purchasing power parity exchange rates, we take the ratio of the prices in the domestic and foreign economies. So for Indonesia, we have the ratio of the price in rupiah of a Big Mac, and we divide that by the price in dollars in the US. And for Switzerland, again, we take the ratio of the price in Swiss francs and divide that by the price in dollars in the US, and we get the following values. These two countries were chosen because they lie at opposite ends of the income distribution. Relative to the US, Indonesia has a rather low level of GDP per capita, and again, relative to the US, Switzerland has a rather higher level of GDP per capita. And these differences are reflected in the purchasing power parity calculations that we've done. So for example, we see that the predicted value for the price level for Indonesia is rather higher than the actual price level, whereas the predicted level of the price level for Switzerland is rather lower than the actual observed value. And this is consistent with the hypothesis that the prices increase with the level of GDP per capita. As a country becomes richer, the production costs rise in terms of domestic labour and in terms of real estate, and so we expect an increasing relationship between the price level and the level of income per capita, or GDP per capita in this case. If we now turn to the exchange rates, we see that the actual exchange rate for Indonesia is higher than the predicted value from the purchasing power parity relationship. But remember, a high value of the exchange rate here constitutes a devaluation or a depreciation because the exchange rate is measured as the price of foreign currency in terms of domestic currency. So in this case, what we're saying is that the actual exchange rate is undervalued relative to its purchasing power parity calculation. Similarly for Switzerland, we see that the actual exchange rate is rather lower than the predicted value from the purchasing power parity relationship. But what this means is that the actual exchange rate is overvalued relative to its purchasing power parity calculation. It's less expensive to buy foreign currency than would be predicted by the purchasing power parity relationship. Now we're going to repeat the purchasing power parity price calculations for all the countries in our sample. So in this table we've got the relevant data, and what I'm going to do first of all is calculate the purchasing power parity price level for each country. So to do that, for example for Argentina, I take the exchange rate for Argentina and I multiply by the price of a Big Mac in dollars. Well, here that's just 4.93 and it's going to be the same for every country in our sample. So I'm just going to type that in directly. That gives me my purchasing power parity calculation. Next, I'm going to copy this cell down for all the countries in my sample, and I get the PPP price levels for each country. Now I'm going to calculate the percentage difference between this price level and the actual price level. So in this cell I enter the formula 100 multiplied by the ratio of the actual price level to the PPP price level minus 1. This will give me the percentage difference for Argentina in this case. Then I copy this cell down and I have the percentage differences for each country in my sample. Now I'm going to see whether or not there's a relationship between the extent to which purchasing power parity under or over predicts the price level and GDP per capita. So if I take this series here, which is income per capita, and I take the series that I've just calculated, which is the percentage difference in price, I'm going to plot a scatter diagram of these two series against each other. So I go to here, insert, scatter, and look at the scatter diagram here. Okay, so if I enlarge that a bit, we can see that there is a clear positive relationship between income per capita, which is measured on the horizontal axis here, and the percentage difference between the actual price level and the implied purchasing power parity price level. And again, this is consistent with our hypothesis that prices tend to increase with the income or level of GDP per capita for each country. Next, I'm going to look at the relationship between the long-term changes in the exchange rate and the price level over the period 2000 to 2018. To do this, I've calculated the compound growth rates for the exchange rate and the price level over this period. The price level data has been adjusted by subtracting the growth rate for the US over this period. Now, I'm going to use the method of regression analysis, and in order to do that I needed to install the regression module in Excel. To get to it, I click on the data button here and then go to data analysis and then choose the regression option here. I now have to set the range for the left hand side variable and the right hand side variable. So first of all, for the left hand side variable I will set the change in the exchange rate, and for the right hand side variable I'm going to use the change in the price level. I then have to give it a output range, so I'm going to output it to the cell E1 here, and if I click on return here, okay, it estimates a linear regression for me. Now there's a lot of information in this linear regression, but the key parameter that we're interested in here is the slope coefficient. This is given in this cell here at 0.9277, and this gives us the effect of a unit change in the growth rate of prices on the growth rate of the exchange rate. So it's telling us basically that if price inflation goes up by 1%, then on average we should expect to see the percentage change in the exchange rate go up by 0.927%, so fairly close to 1. However, this may be the effect of a single outline observation. If we look at our sample, we see that the data for Argentina has much higher values for both the change in the exchange rate and the change in the price level. So an interesting question to ask is, would this result have changed significantly if we'd excluded Argentina from our sample? So again, we can investigate that by running a regression which excludes that first observation. So if I go back to my data analysis option here and go back to the regression specification, I'm now going to set the Y range to exclude Argentina here. Okay. Then I'm going to, for the X range, again I'm going to exclude the Argentina observation. I'm going to keep the same output range here. Click on OK, and it overwrites my regression output. Now if we look at our coefficient now, we see that the slope coefficient here has fallen to 0.63. So excluding the outline observation for Argentina actually makes a pretty big difference to the estimate of the slope coefficient in this equation. It's fallen from about 0.927 to 0.63. So a big outline observation can have very significant effects on the regression output.